In this video, we will understand ARM mode versus thumb mode. ARM processors were designed to deliver high performance, but performance comes at the cost of larger program size. In many embedded systems, memory is limited and expensive. To solve this problem, ARM introduced thumb mode, which provides better code density while still maintaining good performance. Now, let's compare the two modes. The very first thing that we need to understand is instruction width. In ARM mode, every instruction is 32 bits or 4 bytes long. In thumb mode, every instruction is only 16 bits or 2 bytes long. Since thumb instructions are half the size, more instructions can fit into the same memory, resulting in smaller programs. Instruction set size. That is, ARM mode has a large, feature rich instruction set with many powerful instructions. Thumb mode uses a compact subset of those ARM instructions. Although it has fewer instructions, it still supports the operations required for most embedded applications. Code density and memory requirement. Because thumb instructions are only 16 bits wide, programs occupy much less memory. Typically, thumb code is 30% to 40% smaller than equivalent ARM code. This means thumb mode requires less flash or ROM, making it ideal for memory constrained embedded systems. When it comes to execution speed, ARM mode generally offers better performance because many operations can be completed using a single instruction. In thumb mode, some of these operations require multiple instructions, so execution may be slightly slower. So remember, ARM mode prioritizes speed, thumb mode prioritizes memory efficiency. Now let's consider the registers used. ARM mode allows direct access to all 16 registers, that is R0 through R15. Thumb mode mainly provides direct access to the low registers, that is R0 through R7. The higher registers are accessible only through a limited set of instructions. Conditional execution. One of the ARM's most powerful features is conditional execution. In ARM mode, almost every instruction can be executed conditionally by simply adding a condition suffix such as EQ, NE, GT or LT. For example, an add instruction can execute only if the zero flag is set, eliminating the need for unnecessary branch instructions. In thumb mode, this capability is greatly reduced. Only conditional branch instructions support condition codes. Next, we have data processing and barrel shifter. ARM mode provides a complete set of data processing instructions and includes an integrated barrel shifter. This means you can perform a shift and an arithmetic or logical operation within a single instruction. For example, ARM can add a shifted register in one instruction. In thumb mode, shift operations are generally performed separately, requiring additional instructions. Next, we have program status registers. ARM mode allows direct access to the current program status register and saved program status register using the MRS and MSR instructions. In thumb 1 or in thumb, these instructions are not available. So there is no direct access to these status registers. Now let us discuss the CPSR T bit. The processor uses the T bit in the CPSR to determine the current execution state. If T equals 0, the processor is executing in ARM mode. If T equals 1, the processor is executing in thumb mode. Exception handling. Whenever an exception or interrupt occurs, the ARM7 processor automatically switches to ARM mode before executing the exception handler, even if the processor was previously running thumb code. If you consider the typical applications, ARM mode is preferred in applications where maximum performance is required, such as real-time systems and performance-critical code. Thumb mode is commonly used in memory-constrained embedded systems, battery-powered devices, IoT applications, and consumer electronics, where minimizing code size is more important. Let's learn about the thumb instruction set in the upcoming videos.